So there's only one rotating part of our gas turbine engine, and that's the shaft on which the compressors, fan and turbine discs sit on. So to enable that shaft to rotate, we need some bearings, and we have different types of bearings. So we have ball bearings and we have roller bearings. The ball bearings will have force in an axial direction and a small force in the radial direction, whereas the roller bearings will be able to withstand forces in the axial direction only, but they'll be able to withstand a greater axial force. The ball bearings basically allow the shaft to, position itself axially, and the roller bearings are basically there to withstand the large centrifugal forces coming from the shaft. So here's the roller bearings, and you can see if the shaft is running along here, there's greater contact area between the roller and the shaft. So we have this area as opposed to this area here. So that's why the roller bearings have greater resistance to radial forces, but they don't like axial forces. Whereas the ball here, it can rotate in this direction, and it can take some of the axial forces. So just in summary then, ball bearings provide axial location but can carry some radial load. They also generate the least amount of friction, whereas roller bearings will only take radial loads and allow for axial shaft elongation due to temperature changes with no additional load effect on the bearing. Now there's one other type of bearing, or a family of these bearings, and that is the squeeze film bearings. So the shaft is going through the bearing, and there may be some vibration in the shaft, and we can dampen out that vibration by pumping some oil into the bearing in between the races. So we get this little film of oil, so that when the shaft vibrates, this race moves up and down, compressing the oil and then decompressing it, and that dampens out the vibration. So the squeeze film, it's a film of oil, and it just helps dampen out sort of vibrations on the shaft.